Welcome everyone, and thank you for coming to Desco's latest webinar. Today we're going to be dealing with what we call wave distortion monitoring or single wire monitoring. So we'll get started. My name is Greg Heckler, and I'm the Western Regional Sales Manager for Desco. We also have with us today Jeffrey Brake, our Desco Brand Manager, and we're going to be stopping throughout the presentation. In your toolbar on the right there, you'll see a place where you can type in questions. And so Jeffrey's going to be fielding those as we go, and we'll stop a couple of times for that. So let's overview real quick what wave distortion technology is, as some of the unique features. And we'll also be showing you some demos and the different options that all of our monitors have. But wave distortion is our trademark for our single wire monitor technology. And you can see these couple of pictures here. We have one here that's on a pick and place machine, for instance. We have one there in the bottom right on a workstation. But we're talking about continuous monitoring for wrist straps. And there's different technologies, which I'm going to get to right now. But we're also talking about the difference between periodically touch testing your wrist strap versus continuously monitoring your wrist strap. And I'm sure there's a number of you out there that already have continuous monitors, or you're thinking about it, so you have an idea of how this stuff works, but I'm going to go over that. The number one benefit of using continuous monitors is for instantaneous or instant fault detection. If right now all you're doing is walking up in the morning when you get to work, plugging your wrist strap in, pushing that button and getting a pass or fail, that is only one time typically for every 24-hour period. And by the way, that's all the standard requires, is that you test your wrist strap at least one time per day. But the problem with that is that you go to your workstation, if you have a fault, if you have dry skin, if you have a broken coil cord or something like that, you're not going to know for that next 24-hour period until you test again. So the number one benefit of continuous monitors is that you will know instantly when you have a fault for one of those things that I mentioned. Another benefit of continuous monitors, or a great time saving feature, is that when you use continuous monitors, the ESD Association standard allows you to not keep a written test log anymore. When you use touch testing, you have to write your name, date, etc., and record a pass or fail. But with monitors, I don't have to do that anymore. And then obviously, when you're continuously monitoring, you've got a much greater increase in reliability. So I don't have to go back and wonder the next day if I have a problem with my product or something, or maybe a week or a month later, whether I had a broken wrist strap that day. So again, when you're continuously monitored, if something happens, that person, that operator, can stop work immediately and correct that problem. So there are a number of different types of continuous monitors on the market, different technologies. There's four basically. We have capacitance, and this type is one of the original continuous monitor technologies. It was designed originally to monitor what we call a standard single wire wrist strap, which the majority of you use out there. The majority of companies use single wire monitors. And just as it sounds, it uses a one wire type design to ground the body. And this capacitance type basically was designed to monitor the body's capacitance at the end of that wrist strap or at the end of that cord. And it worked pretty well for the original time, but there are some limitations. Primarily that simple changes in capacitance can give you false good readings, if you will. So in other words, you can be getting a green light and everything looks good, but you're not. So we choose not to make capacitance monitoring. We only choose to make the most reliable type of monitor, so we don't have that type in our line. Then there's resistance or resistive loop technology, and you might be familiar with these. You have to use a special dual wire wrist strap, and this basically is like a really fancy continuity tester. It monitors the body's resistance at the end of that wrist straps. Then we have voltage detection. This is a monitor that when you're plugged into it, instead of necessarily monitoring resistance or capacitance impedance, it monitors if you have a charge on your body. So this is also a good technology if you have extremely low sensitive devices and you want to know if you're actually, the things that you do at your workstation, sliding around in your chair, whatever you're doing, if you generate a charge, voltage detection monitors will let you know that. But today we're going to focus on what we call our wave distortion or impedance monitoring. And many of you know that impedance is basically a combination of capacitance and resistance. And Desco has been making this technology for many years, probably close to 35 years right now. And there are thousands and thousands of these in the marketplace that are used by just about every electronics manufacturer you can think of: military, aerospace, medical, high-end commercial, just about everybody you can think of. And so I'm going to focus this presentation on impedance technology or wave distortion and what it does. So one of the challenges with wave distortion or impedance technology is in some cases describing how it works. With a resistance monitor, it's fairly easy because all I'm doing is monitoring resistance from some bottom number to an upper number. And impedance technology also has a lower and an upper limit, but since it's not just resistance only, I have this little diagram of an oscilloscope over here on the right. And the reason we call it wave distortion is because you can see this square wave that the monitor generates. So the way all monitors work is that you apply a test voltage to the body. And then that test voltage measures whatever's on the end of that wrist strap. Could be an impedance, could be a resistance, whatever, and it sends that test signal back and lets you know whether you have a good or a bad reading. So when everything's good, when it comes to wave distortion technology, we have this square or flat wave on the top. And you can see the dotted line there and that line or that square wave touching that line. And so this gives you or showing you that we've got a good connection to the human body right now. All right. Now, if I were to have a high resistance situation, that might be a broken coil cord, your cord fell off your wristband, dry skin, something like that. What happens is now that wave gets distorted, and you can see the right there, that peak is going up above that dotted line now. And so that's where the distortion part comes in wave distortion. So this is a fail high reading or above our upper 10 meg or so limit of the impedance monitor. Consequently, if I have a fail low, and a fail low means basically that my resistor has been shorted somehow in my safety resistor in the coil cord. So if I go below that 1 megohm number of my coil cord, which in our case, our monitors have a bottom limit of 500,000 ohms, then you'll see that left side distort. So this is one way that if you wanted to actually see the technology working, you could do that via an oscilloscope, for instance. I lost my, okay. So, oh, I went too far, sorry. Oh, no, I didn't. Let me start again. Okay, so what I'm going to do, we've got a brand new monitor on the market. It's called a FullTime Continuous monitor. And we've had this in line for a number of years right now, but we've added quite a few new features. So I'm going to focus on this monitor because this monitor includes many of the features that our other ones do, which I'll highlight for you, but this one has it all. And one of the things that I want to point out and make clear too, these are true continuous monitors. Their reaction time is so fast, they're virtually continuous as far as reaction times are concerned. Now this monitor, what sets it apart from the other ones is that it uses an AC regular 3-wire power cord. And one of the reasons we use an AC power cord on this monitor is that it will monitor your AC ground. And I'm going to show you that in a minute. But all of our monitors, they have two things in common. One is they monitor a single operator, and they also monitor the grounds for a single workstation. Now I'm going to highlight a lot of these features, you know, these front and back features, LEDs, connections, and things like that in a minute. Another feature that all of our monitors have in common is what we call our parking snap or a delay. So what this does, this is a great convenience feature that allows you to eliminate purposeful false alarms. And what I mean by that is if you're plugged into just about any monitor on the market and you just unsnap your cord from your band, your monitor is going to alarm. And so if I got up to go to break, lunch, whatever, and I just unsnap my cord, that monitor is going to alarm. So that's going to be a false alarm. And we want to try and eliminate those if we can. So what this parking snap technology does is allow you to touch on this monitor, the blue LED, which I'm going to demonstrate, or the parking snap itself. What that does is that puts the monitor in an 8-second delay. So it gives you 8 seconds to take your cord off of your band and park it on that snap. Now I've eliminated that false alarm. The other benefit of that is with Desco single-wire monitors, you can leave your coil cord parked at that workstation or that monitor. So that gives you the benefit of no matter what workstation you go to, there's always a cord waiting for you there. Keeps them from hanging on the ground and getting run over by your chair, or puts less stress on the strain relief. There's a number of benefits, but this parking snap technology is really cool. Now on this monitor, we have an additional feature of having an embedded relay. So this green connector right here would allow you to hook up something like, oh, say a door solenoid. If I wanted to open a door with this monitor, once I put my wrist strap on, that relay will kick in and open that door solenoid. So this is the only single wire monitor on the market that has that internal relay. Also, an accessory jack. I'm going to show you another option that we have, but we have an optional relay box that is, this is the first time we've built a monitor with digital technology that will allow you to turn things on your workstation. For instance, if I don't want my soldering iron turned on until I'm wearing my wrist strap, this monitor and that optional relay box is going to allow you to do that. So do we have any questions? We'll take a little break right now, Jeffrey.
We do have one. Can you comment a little bit about what the ESD Association's requirements are or for monitors?
Okay, that's a very good question. There is no requirement for continuously monitoring your wrist strap. As I mentioned before, there is a requirement for testing your wrist strap, and that is at least 1 time per day, and that applies to both foot grounders and wrist straps, but you must or shall test your personal grounding devices at least 1 time per day. The monitor does, or the standard does allow you to write a tailoring statement into your ESD plan for the use of continuous monitors. So as I mentioned before, you're allowed to eliminate the written test log if you were to use a monitor. So you would just write into your plan that that's what you do for wrist. Okay, so you just write into your plan that you're going to use a continuous monitor for testing your wrist strap. Another question, Jeffrey?
Yeah, there's one more question about, can you explain the reason for the necessity of the lower limit, the 1 megohm resistor in a wrist strap, and then the reason we monitor for it, or the reason monitors monitor for it?
Okay, if you're currently touch testing right now, that touch tester has 2 results that you may get. One would be a fail low and the other would be a fail high. And as I mentioned before, when you're failing high, that's a high resistance. So I'm going above the upper limit of the tester. However, all wrist straps, coil cords, have a 1 megohm safety resistor in there for personal safety to keep you from getting shocked, if you will. And so we also incorporate that into our single wire monitors. So our monitor will also alarm and let you know if you have a personal safety issue, if that resistor has shorted. So that's something you should definitely keep in mind, or that's a feature you should want when you're choosing continuous monitors. Okay, Jeffrey?
Okay, I think that's it for now. I'm going to turn on your webcam. You're going to do some demos, right?
Yes. Okay.
You got it. There we go.
All right. Take my old man glasses off here. So I have a typical bench setup here, or a standard workstation here. And I have a number of the models that I've been talking about, which I'm going to show you. Now I have our latest full-time continuous monitor mounted up here, so it's easier for you to see. But this could be mounted, here's the unit right here again. This could be mounted under the front of the workstation, could be mounted on the side of the workstation, on the side of a leg, wherever you want to mount it basically. I showed you that we also had one mounted on a pick and place machine. So to this model, we've added these mounting ears, and we also have another monitor that I'll talk about. We have that also, but you can mount this in many different ways. So this is just up here right now, so it's easier for you to see. Another model that we have is what we call our mini monitor. Some of you may have these, they're very popular, but this is our most base model, if you will, when it comes to features. All of the technology and all of the three monitors I'm showing you are all wave distortion. It's just a number of them have more convenience features than other one. And one of the nice things about this monitor, you can see how small it is obviously, but it has these two snaps on the back, 10mm studs, if you will. And this allows you to just snap the monitor or screw the monitor right to your workstation. So if you want a really easy way to jump into monitoring real quick, it's also fairly economical. You can just pop that onto your workstation, plug it in, and you're ready to go. This model here, this is called our multi-mount. Again, this is the same size as the other one. This one has the mounting ears, but one of the big advantages of this monitor, it has warning LEDs on the top, and it has warning LEDs on the front. So again, no matter how I mount this, I'm able to see these warning LEDs. Now this monitor includes some additional features over the mini monitor, a couple of them, and I'm going to hit on all these again, but this one, I can adjust the audible volume of the alarm, and I can also turn the mat circuit on and off if I want to. So again, if I was just monitoring a cart shelving unit, pick and place machine, something like that, I wouldn't need to use the ESD mat circuit. So I can shut that off. Now this monitor, I'll just get into these settings right now, but one of the things I want to touch on is the mini monitor and the multi-mount monitor are powered by a low voltage 3-prong transformer, as you can see. So all of our monitors use AC ground to bring the ground to the monitor. You do have an additional ground connection for your work surface, but we use AC ground to ground the operator. There's some additional features when it comes to this one, which I'm going to touch on, but just so you know, that's how the ground gets to the monitor. So let me get to our latest technology. Again, as I mentioned before, this is the first digital monitor on the market. So this is going to do a number of things. One thing, and the reason why it was developed in the first place, is one, it actually monitors your AC ground. So if I lost my AC ground, let's say the green wire fell off of my receptacle at my bench, this monitor is going to alarm. And the way we can demonstrate that is, many of you have seen these before, these little 2 to 3-prong adapters. So if I had an old house and it only had a 2-prong receptacle, I could plug in a 3-prong power cord to this. So what this allows me to do is to remove the AC ground to demonstrate that feature. So I'm going to unplug the monitor real quick. I'm going to plug this in here, back into my electrical receptacle. And so far, you've noticed the monitor has been very quiet. Okay, I'm going to plug this back in, and now you're going to get that obnoxious alarm and warning letting you know that I've lost my AC ground. So that's the only single wire monitor that allows you to have that feature or that warning system. All right, so I'm going to plug that back in. So I'm going to put my wrist strap on right now. And I'm going to show you that under a normal state, you can see all these green LEDs. And I also have this continuously lit blue LED right here. So everything's wonderful with the monitor. My body's under the specific amount of required of resistance, impedance, and we're ready to go. If I were to have a fault, as the case with any of these monitors, okay, now I'm going to get that audible alarm. I'm also getting a red LED, which may be hard for you to see on the camera, but now I'm getting a red LED on my monitor, okay? So that would happen with any monitor. Now, the other thing too is, as I mentioned before, all three of these monitors monitor ESD work surface connections. Now, I want to emphasize, continuous monitors do not monitor surface resistance of your work surface. They monitor the ground connections. So over here on the left side of my mat, I have my ESD ground, and then on the back, I have my monitor ground. So if, for instance, my mat would fail, I get an alarm. So if the cord would fall off, maybe you reconfigure your workstations and facilities doesn't hook the grounds back up, you would not know that until you walked by and saw it, unless you were using a continuous monitor. So even though that's an additional feature of monitoring, it's a very useful feature when it comes to overall monitoring of your workstation. So I have a list of features which I'm going to kind of go through really quick. So we monitor MAC grounds. I talked about this one, monitor AC ground. Now let's talk about the speed. This monitor right here and our mini monitor, these things will alarm or react in less than 50 milliseconds. That's one of the fastest monitors, if not the fastest monitor on the market. Certainly the fastest single wire monitor. So if you have a break in your connection, you're basically getting an instantaneous alarm. The FullTime monitor, that's less than 100 milliseconds. So it's extremely fast also, all right? Again, I mentioned the parking snap, so let me hit on that. So let's say I'm gonna go to lunch right now. And normally, if I took this off, I'm gonna have an instantaneous alarm, and you're gonna look around, what's going on? Well, I just went to break, right? So this monitor and all of our others allow you to touch this parking snap, okay? Again, it puts the monitor in a delay, and it gives me up to 8 seconds. Notice I've got the red LED, if you can see it, okay? If I don't park it, I'm gonna get an alarm. So again, I'm grounding myself right now. I'm gonna do this again. I take my snap off. Now I park the monitor, or I park the cord, and the monitor's in that parked state. You'll also see, if you can see it, the blue LED is flashing. So if I were a supervisor or somebody, I could easily walk by this monitor. On the others, I get a red LED with no alarm. I can easily walk by these monitors and note that they're in a park delay state. So when I come back from break, I pull this off. I have 8 seconds, okay? I touch connect my wrist strap cord, and again, everything's normal. So that's a great convenience feature. And again, like I mentioned, one of the nice things when I park my cord, I put a lot less strain on my strain reliefs too. They hang nicely, they don't lay on the ground, etc. So that feature is a really nice feature. Okay, now another feature that this particular monitor has, and with our new digital technology, we've not only have the internal relay system, but we also sell an optional relay box, which you may be able to see down here. And this allows you to plug in AC powered tools or equipment and not allow those to be energized unless you're wearing your wrist strap. So I'm gonna put this back on. I don't have this connected, so I'm gonna reach behind and connect my my wire. And this is fed by an a telephone cable. So I'm gonna hook this up, turn on my relay box. Now you heard that beep. As soon as my relay box was on and I have my connection going, it turned on my ionizer. So that could be your whole workstation, the plug strip, a specific item, maybe a microscope light, whatever it is, a number of things. This relay box handles quite a bit of amperage, so most likely you can power just about anything you've got on a typical workstation. If I fail, you'll see the relay, you'll hear the relay kicks in and the monitor alarms, and it shut my ionizer off. When I have a good connection, relay kicks in, and now there's a little bit of delay in there because it just the design of the way it works. You need a little bit of delay for that circuit to work. But as soon as you make a good connection with your human body, that relay kicks in less than 2 seconds, and you're ready to go again. So if you're looking for something as a foolproof way of making sure that person is grounded, before they start to work, this monitor is the way to go. Now, I mentioned also that two of our monitors, this one and the multi-mount, they also have an adjustment for the alarm system. I'm in a small room right now, and you could hear how loud that was. If I was just in here by myself or maybe 2 or 3 people, I might want to turn that alarm down for convenience. If I'm in a louder factory, maybe 100, 200 benches, you might want to turn it up. We get calls. We had calls like that for a number of years. Can you make your monitors louder? Well, that's what we've done, and now we've added that adjustment, okay? So I talked about the embedded relay, and one of the other things I wanted to make mention of is, or reiterate, is that very low test voltage. Desco monitors only put 1.2 volts on the body and only 1 to 2 microamps. So unless you've got extremely sensitive low class 0 circuitry, these monitors are safe for just about any level or classification of devices that you can work on. Do we have any other questions right now, Jeffrey?
Yeah, can you demonstrate the monitoring of the, well, 2 things, 2 parts, the banana jack and how that alarms, and then the park delay and park snap, if you can, when you disengage the banana. Can you demonstrate that for us?
So that's a very good question. So these monitors also have a feature of, let's say that I get up, I walk away, or I roll my chair over, I stretch that out, and I yank my banana plug out, okay? So if I do that without parking it, I'm gonna get an alarm, and that alarm's gonna last for 8 seconds, and then it's gonna stop. So again, this is another great warning feature that something's happened that wasn't supposed to. That's a legitimate fault. When I plug back in, I'm ready to go again. So again, if I don't want that to happen, I can touch my parking snap. Oh, hang on, I did it wrong myself. I can touch my parking snap, I can disconnect, and then I can park the cord again, and I'm ready to go. So that banana jack alarm is a great feature, especially if you, like we make very durable, tight-fitting banana plugs and jacks, but there are some wrist strap cords on there that the springs break easily or they get sloppy and loose, and it wouldn't be uncommon to yank. In fact, I've been in many places where people are taping their banana plug into their jacks. So that's a great feature so people don't accidentally, or if they accidentally, remove their banana plug. Another question, Jeffrey?
Can you unplug the power control relay and give us a sort of a close-up of it and
Yes.
explain sort of some of the functions of it?
Okay.
There's a couple questions about kind of what that looks like. I know we didn't have the opportunity to do that earlier.
Okay. So I'm going to plug the power cord, but so we have this box right here. You can probably see it better now. It has normally closed and normally open settings, okay? And then this telephone cable here powers goes to the monitor to make the electronic connections. And then we have an on and off switch for the box, all right? So normally what you would do is you would plug, if you have multiple things to control, you'd normally just plug a plug strip into this and then plug all the different items that you would want to control into that plug strip. But it does have two, I think these are normally off or normally closed. So when the monitor kicks in, then it opens that circuit and powers those devices. So this is an option. You don't have to use this, but you can if you want to. And again, if I just wanted to say open a door or something, then I can use the relay connections on the back of the monitor. So this is the telephone connection, relay connection. This is the screw to connect the mat circuit to, and the IEC power cord, okay? And again, this one's a little bit larger because it's got a lot of technology in it, but it's still quite small that I could fit under the front of a workstation, on the side of a leg, wherever I might want to mount that. Another question, Jeffrey?
Yeah, kind of maybe you can comment on this. It's not necessarily a question, but they're asking sort of why would you power your ionizer with your monitor I did try to answer this in writing too, but the basic idea there is that if you failure with your wrist strap, you want the person who's at the workstation to stop working, correct?
Yes, or not be able to start work in the first place.
Yeah,
That's
that would be the other option. Yeah.
Right. The whole point of this circuitry or this design is to keep an operator from working on static sensitive circuitry unless they're grounded. I just happen to use an ionizer as an example of what it could power. However, one of the biggest, when I'm out in the field and I'm at customers and I'm doing ESD surveys and things like that, you'd be surprised how many companies have ionizers and the operators don't have them turned on. So that's really actually an extra nice feature when it comes to ionizers, because now that ionizer, when I plug my wrist strap on or put my wrist strap on, that ionizer is going to be turned on. So that's a nice feature. So I'm just using that as a demo, but it's a great feature to make sure your ionizers are being used.
Gotcha.
Other questions?
Can you the couple questions about calibration requirements?
Okay.
What are the calibration requirements for a monitor? And actually, somebody's asking about the power control relay. So
okay. Well, we for a calibration standpoint, Desco recommends annual calibration on all of our electronic products. Could be an ionizer, could be a monitor, whatever the electronics type item that we make is. You have to decide, how often you want to calibrate. We recommend annually. For our monitors, we do have another convenience product. We manufacture a limit comparator for our Wave Distortion Technology. So you can purchase that and do your calibration in-house. There are third-party outside sources that can calibrate our monitors. Many of those companies use our limit comparators to do that. So you could do it in-house, you could do it outside, you can send them back. But with our limit comparator, the nice thing is now I don't have to demount the monitor, especially if they're screwed to the workstation. So the limit comparator is inexpensive, and it's a great way to save you a lot of time and money on calibration costs. Okay, Jeffrey?
And the power control relay doesn't require any calibration, right?
No, that's not something, no.
Okay. I'm getting more questions here very quickly. Let me see if we can answer some quickly. Let's see what we got. Yeah, can the power relay be connected to the bench or the bench lights? That's a question, but that's an example of controlling the ability to start the operators start their operations before they're grounded correctly, right? So
yes, as an example, this workstation that I have here is powered, the plug strip along the back is powered by an AC power cord. I could simply plug that master power cord into my relay box, and now I'm controlling all of my outlets. So that's why I say you might set how many things you want to control into a plug strip, and then you plug the plug strip into the box. The only limitation would be going above the amperage capability of the relay box. But this will handle quite a few amps, and just about everything I could think of, from the light to a soldering iron to an ionizer to a microscope lamp, a magnifier lamp, whatever, you're not going to exceed the amperage rating of this relay box.
Can you, yeah, we got another one. Can you demo a low limit fail? What that would look like? Do you have it?
Yes, I can. I'm going to reach over here and grab a cord that I have over here. So this coil cord that I have in my hand has got a red head on it. And the ESD Association standard requires that if I have any personal grounding item that is less than 1 megohm, you have to identify it with the color red. So this is a coil cord without a 1 megohm resistor, and it's colored red. So I'm going to attach it to my wrist strap. Oh, you know what? I'm going to hold this one in my hand because I have a magnetic wrist strap on. So I'm going to plug it into my monitor. Give it a second. Now the red light lit, okay? And I'm gonna get, I get an audible alarm because even though I'm grounded, I'm below that 1 megohm limit of the monitor, all right? Whereas I can take my regular coil cord with the 1 megohm safety resistor, and now everything is good. So these monitors will let you know if you have a safety hazard present. If you dip below, well, this monitor has a 500K lower limit. You dip below that 500K and you're gonna get a fail red. Another question, Jeffrey?
I think that's it. There are a few questions that we'll follow up with separately on an email or a phone call. So I think that's probably it for now.
Okay.
I appreciate it. Thanks, Greg, for that, all the demos today.
Yeah, no problem. Thank you for coming, everybody. We appreciate it. As Jeffrey said, he's going to touch on a couple of things, but a lot of information, but we'll be happy to answer your questions. So send us email and let us know.
Great. Thanks, Greg.
Mm-hmm.
Couple things just to finish up here. Our evaluation program, if you want to see one of these monitors or demo it, we have a group of sales reps that have these units. They can come to your facility and demo it. They can also drop it off with you and let you use it for a few days. The other option we have is that you can purchase one from us directly. We'll offer you 120-day terms. We can set up a conference call to review the monitor with you before you set it up so you know what you're doing. We're happy to do that. The best way to do that is to just call or email us, and we'll start down that path. So again, we want to thank everybody today. Greg Heckler for doing the demos and most of the presentation today. Appreciate your questions. If you have anything else, please feel free to email or call us when available. Thanks again. Have a good day.
Thank you.